Greetings. This is to be a lecture on the origins of Western science, and that should inform our discussions of the philosophy of science and various philosophical issues that arise from the practice of science. So that's the plan here. And so let me begin by sharing my screen. How do I do that? It used to be easy. Here. Yes. Share. Okay. And even though this is the edit mode, I think I'm going to leave it this way because sometimes I see mistakes as I'm doing the presentation, but if it's in presentation mode, I can't fix the mistakes. So I'm going to take this as an opportunity to fix mistakes as they appear to me during the presentation. So it's sort of a work in progress, right? So years ago, I was invited to be participate in the Honors College first year seminar. And they had a course that they offered at that time called Ideas of Origin and Origins of Ideas. And all of the faculty who participated were invited to give a lecture or two throughout the semester. And each week, a different faculty member would give a lecture. And I was specifically asked to give a lecture on how does science give us knowledge. And I agreed because I was trying to stay on everybody's good side. But it occurred to me, how would I know, right? And actually that kind of is a joke that works on several levels, right? Epistemology, how do we know, et cetera. Okay, but you know, I'm not a scientist, of course. I'm in the philosophy department and my training is in philosophy, not science. So anyway, but I consented and I'm glad that I did because I enjoyed doing the research and coming up with this presentation. So that's where this comes from. But I think that if we're going to talk about how does science give us knowledge, and then more specifically, what is the kind of knowledge that science does attempt to provide us with, it's important to sort of understand a more fundamental question: what precisely is science? And it's probably a good idea, I think, to go back to the origins of science. Now, the following set of lecture slides are slides I shamelessly cannibalized from a presentation that I created for my Introduction to Philosophy class, which was my Welcome to the Wonderful World of Philosophy. And the reason I shamelessly stolen those slides was because, number one, it was already written, and number two, it seemed appropriate. Now, what do I mean by that? It seemed appropriate? Well, I mean this: the origins of Western science share the origins of philosophy. Philosophy and science began at the same time, and the same individual is considered the founder of Western philosophy and the founder of Western science. And if you've actually sat through my lecture on Welcome to the Wonderful World of Philosophy, if you're in a course where that's something we've already gone over, then you may want to return to some of those notes to review them. I'm only going to give a sketchy revisiting of those notes in this presentation. I don't know, I need to go into all the same details, but that's the origins of these notes. And if you would like greater detail on that, of course, let me know and I can either provide you with those notes or direct you as to where you might find them. So then, welcome to the wonderful world of philosophy. So as a side note, there at FIU, no upper division philosophy course has a prerequisite. This means it is often the case that I have students taking my upper division course with me who perhaps never have taken a philosophy course before. So the first philosophy course they take is an upper division philosophy course like philosophy of religion. Last semester, I taught an upper division course in philosophy of science, and I had at least 3 students in there who had never had a philosophy course before. So this being the case, I created a presentation that I give in almost all of my philosophy courses, where I just want to make sure we're all on the same page. And so even if you have had philosophy before, I think it's helpful for you to understand how I understand philosophy, what I think about when I think about philosophy, what I think characterizes philosophy and its relationship to science and its relationship to religion and other fields of inquiry. So I do this presentation in almost every course I teach. Now, that is, I do this presentation, Welcome to the Wonderful World of Philosophy, in almost every course I teach. So you may have already had it if you're sitting in one of my courses right now. On those occasions that I have omitted giving this lecture at the beginning, I nearly always have regretted it. However, you're only going to get a portion of that introductory lecture today, and I'm tweaking it to make it specifically tailored to this portion of our philosophy of science. So there are two parts to this introduction to philosophy, where I talk about the methodology of philosophy, what is it that philosophers do, and then the subject matter of philosophy. What are the perennial issues of philosophy? So what do they do, and what do they do it with, right? And I will be concentrating on number one and only making passing remarks about number two for reasons which will become clearer later on. So in speaking about the methodology of philosophy, I like to point out that both philosophy and science are considered to have been founded by Thales, Thales of Miletus, or Thales of Ionia. Ionia was a region on what today is modern Turkey, and it was a Greek colony, and the city in which Thales lived was Miletus. So that's why it's Thales of Miletus or Thales of Ionia. He's considered the founder of Western philosophy and the founder of science. Little of his work survive. Actually, more precisely, none of his work survives. Mostly what we know about Thales, we know because of what other people had to say about Thales. So we're taking it second and sometimes third hand. But we are pretty confident of this one thing that Thales is alleged to have said, and that is he is famous, or perhaps even infamous, for having claimed the following: everything is water. Now, the significance of this bold pronouncement that everything is water may not be readily apparent. So I think it's better explained in the time and the culture in which he lived, and what Thales was up to, and what led him to make this bold claim that everything was water. So Thales was from ancient Greece. Again, it was a Greek colony on the coast of what is today Turkey. And the Greeks were a very inquisitive people, perhaps no more inquisitive than other peoples of the world, but they were indeed inquisitive. So they had lots of questions, like, why does the sun cross the sky every day from east to west? But notice they didn't merely have questions, they actually had answers to many of these questions. So if you ask the ancient Greek person, why does the sun cross the sky every day from east to west? Likely they will tell you the story of the god Apollo, who drives his fiery chariot across the dome of the sky every day from east to west. Right? However, these answers to the questions that they had were not so much considered explanations in our modern sense, but what we might term mythos, by which I mean narratives which attempt to unify experience into a single coherent whole, often employing supernatural agents and forces which are believed to underlie the visible. In other words, by appeals to gods and goddesses and magic and this sort of thing. So the key takeaway here is that the kinds of stories that individuals were interested in telling about the world in order to make sense of the world were these narratives. Again, these imaginative stories. And in a narrative, you have various elements, characters, events, and all of these are unified within the narrative so that it all becomes a coherent whole and it kind of makes sense. There's a sort of gestalt to it where it's not just dissonance, it actually is consonance. It sort of makes sense, but it makes sense by the way of being a coherent narrative. Note that nothing is more natural for humans beings to do than to form narratives out of the various desperate experiences in order to make sense of things and gain perspective. For instance, when you come home from school after your classes and your mother asks you to tell her about your day, what do? Well, you take your day, which was a series of seemingly unrelated or barely related events, etc., and you turn that, weave that into a story that has some kind of a beginning and a middle and an end, and it follows a narrative arc and direction. Well, I got up a little late, so I rushed out the door without the paper that was due today, you tell her. But I couldn't come back to get it because I had a test in my first class. So after my first class was over, I went over to the library to see if I could print out my paper from my Dropbox account. At first, I couldn't get it to work at all, and I was worried that I'd be late for my second class. But at the last minute, I figured it out. So then I finally got to class with my paper, and the professor told us that he was extending the deadline. After all of that, I decided I needed, so notice I didn't need that stupid paper in the first place. So after all of that, I needed to treat myself, and I bought myself a smoothie. Then I met my study group around 3 p.m. and I gave Becky a ride home after we were done. All right, maybe not the most interesting story arc in the world, but notice what did you do? You focused on certain events, you wove them together and so that they led into the other, and you built a coherent picture of your day, and you built that coherent picture of your day by turning your day into a story. Again, you filtered out certain events and focused on others. For instance, you didn't tell your mother how many times you blinked your eyes or how many times you breathed in or breathed out. Those were events that happened in the day, but you passed over them and ignored them so that you could focus on others, and that's part of the narrative process. Another myth that was popular in ancient Greece was the Persephone-Demeter myth, which tries to explain why the seasons change. You might be familiar with this myth already, but the idea was this: the earth goddess Demeter had a beautiful daughter, Persephone, whom she cherished and loved and adored. But one day when Demeter was off doing various earth goddess chores, I suppose, Hades, the god of the underworld, comes up from the underworld, kidnaps Persephone, and takes her down into the underworld to live with him there as his queen and consort, right? And it's a longer story, but I won't go into all the details, but because she ate 6 pomegranate seeds while she was there, Zeus decreed that for 6 months out of the year, she did indeed need to stay with Hades in the underworld and be his queen and consort. But then for 6 months out of the year, she could return to the upper world and be with her mother, Demeter. So in the fall, when Persephone once again leaves Demeter, Demeter becomes so bereft and so heartsick that her daughter is being taken from her yet again, that she neglects the world. And everything becomes cold and barren and harsh, and it will not bear fruit. But in the spring, 6 months later, when Persephone returns to Demeter, Demeter becomes so overjoyed that Persephone has once again been restored to her, that the earth bursts forth with new life, and trees bud and flowers blossom and bloom, and all becomes rich and fertile again, because Persephone has been restored to Demeter. I mean, it's a nice story, right? And it makes sense. And it tells you that, oh, yes, all the leaves are falling off the tree now, but don't worry, that just is going to reverse itself in 6 months and everything will be fine once spring comes around, right? So it's a way of making sense of the world and the events of the world and predicting and planning on those predictions, etc. So example, why do the seasons change? Answer, the Demeter-Persephone myth. Mythos narratives were not meant to be testable hypotheses. 2 important features of Greek myths to be noted, however, are these. The answers to these questions usually invoked supernatural powers for presumably natural phenomena, like the sun moving across the sky or the changing seasons. But also, these myths were supposed to have been revealed to mortals by the gods, or the gods' spokespersons, right? That meant they carried with them divine authority. And if you questioned these myths, if you challenged these myths, if you rejected these myths, well, this was essentially to question, to challenge, or to reject the gods themselves. This was not only a religious sin, but it was also a political crime. It was a political crime that carried with it harsh punishments. The reason for condemning heretics was because they were considered to be questioning the gods' authorities. The political climate was not liberal, since the survival of the community depended on everyone conforming to the same rules. These little city-states in ancient Greece were like lifeboats of civilization, outside of which a decent human life, meaning family, friends, creature comforts, etc., security, was impossible. Well, the last thing you want in your lifeboat is somebody rocking the boat, somebody not getting along, somebody questioning the political order. The survival of the community depended on conformity. And so that kind of rebellious behavior was not encouraged and it was not tolerated. Now back to Thales. Thales was curious about this notion of change. In any change, there must be something which is changed, something which undergoes the change. But okay, we've already got a paradox then, because the something which is changed must endure throughout the whole process. So it's that enduring something, but it also must be changed. So it doesn't endure throughout the process. Can the same something which endures be the something which doesn't endure? Notice that which is becomes that which is not. It's weird when you think about it. How can something be what it isn't? And how can something that isn't come to be at all? And yet this seems to be what is required by any instance of change. For these sorts of reasons, the ancient Greek philosopher Parmenides, came along later, argued that change was in fact impossible, right? Parmenides had argued that change is an illusion because it just seems so paradoxical. But that wasn't Thales. Thales had a different idea here. He predates Parmenides, by the way. So let's use the sort of silly example. If a cow eats grass, the cow can change it into milk. Of course, I've had students point out to me that the cow changes the grass into other things as well, but we're going to focus on the milk. So notice we have the grass which changes into milk, grass which is green, solid, and leafy, and milk, which is not green but white, which is not solid but liquid, and which is not leafy but, for lack of a better word, milky. Right? So it's pretty clear that grass is not milk and milk is not grass, and yet somehow the grass is the milk or becomes the milk. That's the change problem, right? I've had a student point out to me there's another qualifier I could put on this list of distinctions between grass and milk. Grass is inedible, right? It has no nutritional value for human beings, and yet milk can sustain an entire village. So this is perhaps why in certain cultures the cow is regarded as kind of miraculous, because it can take what is essentially worthless and turn it into something which is vital for the health of the community. Well, what Thales suggests is that there must be some enduring stuff, a substratum, a substance, which stands under the observed change. So what we observe are sort of superficial top-line properties, green, solid, leafy. But the substratum, the substance, is holding up these properties, but it's again lurking beneath the properties. We don't observe the substance itself. But then that substance is somehow reconfigured. And so that the very same substance, which was previously holding up green, solid, and leafy, later is holding up the appearance of white and milky and liquid, right? But it's the same substance throughout. So the substance endures underneath the shifting appearances. This is Thales' resolution to the problem of change. And change is going on all the time, everywhere. It's ubiquitous. So Thales reasons that there must be a basic substance of everything. Now, what could that basic substance of everything be, which underlines all of reality? Well, you already have his answer, right? He reasons that the basic substance of everything is water. Now, why does he pick water? Well, he was probably already working within a framework of basic elements. Many ancient cultures were, right? 4 basic elements, to be precise: water, earth, fire, and air. And that the various objects that we encounter in the world are some combinations of these 4 basic elements. But of the 4, he picks water as the most basic of all 4. And why is that? Well, it's not really clear why, right? Again, we don't have his direct writings, but we can theorize that, number one, it's certainly versatile. Water can be solid, water can be liquid, water can be vaporous, gas. And so it seems to be able to assume all the states of matter that he would have been familiar with. But then beyond that, it certainly is very plentiful, right? I mean, there he was living on the Aegean Sea, lots of water, right? Water everywhere. You dig down far enough, you're going to start hitting water, and half the time it's falling out of the sky. So it certainly seems to be a ubiquitous and plentiful substance as well as versatile. Pleased as he was with his discovery, he was eager to share it with his students. And so he did call his students in, and he is going to share his new idea that everything is water. Unfortunately for Thales, perhaps fortunately for us, it didn't go over well. Now notice, since he thought it up by himself, he was not given to him by the gods. He wasn't claiming that his theory was a myth that had divine authority. It had no more authority than that of an ordinary human being. So when he put it to his students said, well, look, if the gods didn't tell you this, Thales, if the gods didn't tell you that everything is water, why should we believe you? Well, he gives them his best reason and argument and evidence in support of his case. And he does his song and dance about, well, change requires a basic substance, and there has to be a basic substance of everything, and water is very versatile and plentiful, and blah, 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 blah. And he asks him, what do you think? But frankly, they don't think it's a very good theory. And they immediately point out to him that there are dry cliffs over there in Turkey, where he was, and these dry cliffs were dry. Water is wet. There's no way these dry cliffs can, in fact, be water. So there's no way his theory could be correct, right? So what they were pointing out to him is what's called a counterexample. A counterexample would be facts or observations which are incompatible with the truth of a theory, and thereby show the theory to be wrong, incomplete, or otherwise flawed. They, his students or successors, took on the challenge of coming up with a better account. A little while later, you had another philosopher, Anaximander, who suggested that the basic substance of everything had to be more basic than water, had to be more basic than air or fire or earth. In fact, it had to be so basic, he called it the undefined, the boundless. And this is what he suggested the basic substance of everything was. But this in turn was criticized as being too vague, right? It doesn't seem the boundless. Well, that doesn't really tell us very much, isn't very helpful as an explanation. A little while later, you had the philosopher Democritus, who suggested that the basic substance of reality were minuscule particles which were so tiny that they couldn't be split into anything tinier. He called them no splits, with the idea that they can't be split up in anything, right? They are as small can get, right? And change, Democritus suggested, was the result of compositions and dissolutions of these aggregates of no splits, right? The coming together and the falling apart of these architectures of no splits as they move about in the void of space. And so you have an enduring substance, the no splits, but change is simply the reconfigurations of these in space. Now, of course, the Greek for no splits, hopefully you saw this coming, is atom, right? No split. And so what Democritus is suggesting is that the basic substance of reality is atoms, and change is simply the reconfiguration of assemblages of atoms as they move about in the void of space. Of course, the Greek word for no split would be atom, right? It's worth noting that it was not far, intellectually, temporally, or even geographically, from Thales, everything is water, to Democritus and atomic theory. I recall reading one time a treatise on the history of Western science one time, and it covered pretty much the same grounds as we just went over, Thales to Anaximander to Democritus, etc. And it seemed that science was off to a good start, or so the author contended. But then the author suggested that Plato happened and derailed science for the next 2,000 years. Well, I don't think that's quite fair to Plato, but I see his point. Back to Thales. So Thales is considered the founder of Western philosophy, not because his theory was so well received. In fact, his theory was shot down almost immediately. The importance of Thales is that he presented a theory that could be shot down, and he specified the criteria by which it could be shot down. Thales is considered the founder of Western philosophy because he starts a philosophical conversation and he set up the rules for the dialogue. Notice that Thales is advancing a theory based on reason, argument, and evidence. And it could be supported by reason, argument, evidence, but it could be undermined by more reason, more argument, and more evidence, which is precisely what happened to him. So that's the rules of the dialogue. You present your theory, and then you give your best rational support, but then you have to critically evaluate it and see whether or not that support is sufficient or not, or whether there might be alternative facts which act as counterexamples to your theory, etc. So this is the difference between what we were calling mythos, the narrative, imaginative process, and what I'm going to term logos, which is this rational process, trying to understand the world through reason, argument, evidence, and observation. So this, I maintain, is the philosophical methodology: theory postulation, justification, critical review, and revision. You present your theory, everything is water. You give your best justification, blah, 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 change, blah, 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 substance, blah, 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 water's plentiful and versatile. Critical review, wait a minute, Thales, there's these dry cliffs, you have to account for those. And then revision. Oh, maybe revision just means you patch it up a little bit, or maybe revision means you do something much more full scale. But if necessary, you need to revise your theory to make it consistent with the reason, facts, and arguments in evidence. But notice, step number 4 loops us back to step number 1, because once we have a revised theory, it may require additional justification. It invites further critical review. Potentially new revisions will be required, etc. So this loop around process is called the dialectical process. A dialectic is the art or practice at arriving at truth by the exchange of logical arguments. It offers a different sort of or mode of rationalizing the desperate experiences from mythos. So the dialectical logos is set apart from mythos as a means of trying to understand rational, make sense of the world. Logos is offering testable hypotheses supported by reasons and subject to critical review and evidential revision. But further, no divine authority is claimed or evoked. Therefore, questioning the adequacy of any human-generated explanation is not an impious or sinfully prideful act. There's a kind of inherent democratic quality built into philosophy here, because what one human being thinks up, another human being is in just as good a position to critically evaluate and potentially discredit, right? Also notice that Thales was proposing natural explanations for natural phenomena. He wasn't talking about anything supernatural in his account of these changes going on in the world. So logos is a Greek word for word or law or principle, right? Logos as a Greek word, it can be translated a couple of different ways, but word is a perfectly suitable translation. So is law, principle. It can also be translated as meaning. The psychiatrist and philosopher Viktor Frankl developed a kind of psychological counseling, which he called logotherapy, where he thinks that the job of the therapist is to assist the client in trying to find meaning in life, right? Logotherapy, right? The Greeks were committed to the idea that rational principle, logos, governs and develops the universe, that the universe is structured rationally and it develops and changes rationally. Now, this rational principle in the universe is also in the mind of human beings, and it's what makes understanding possible. So philosophy, philosophia, is born out of this commitment to discover the rational universe rationally. Right? So philo, love, and sophia, wisdom. So philosophia is the love of wisdom or the pursuit of truth. Logos. But of course, this is not the only methodology of philosophy. It's also the methodology of science, or at least in broad outline. Thales' dialectic continues today in philosophy and in science. Think about it. Science operates in the same way. Theory postulation, justification, critical review, revision, and the critical review often takes similar formats, right? You publish it in a journal, you present it at a conference, you publish a book, you have conversations with your students, right? But you subject your theory with its best evidence argument to critical review. Maybe you just think about it a little more carefully yourself and, review your facts and figures and calculations. But this goes on in philosophy and in science. But that raises the question then, so if philosophy and science are similar in that they share the methodology, the commitment to dialectical process, how do they differ? Well, for a long time, they didn't. Science, or what we might call scientia, is the Latin, was understood to be inquiry, generally. And what we call natural science today would have been referred to as natural philosophy, differing in the object of inquiry, but not in the mode. Any adequate understanding of the world or reality required asking and answering questions today that would belong both to the separate disciplines of philosophy and science. Understanding how and why that changed will go some way into understanding how it is that modern science can give us knowledge. And perhaps as importantly, the kind of knowledge that science can give us. Medieval science. No, that's not an oxymoron. However bad the ancient Greek philosopher Aristotle's physics, astronomy, and meteorology might have been, he is recognized as an important scientist and a biologist. His careful biological observations were not surpassed until the invention of the microscope. He had his former student, Alexander the Great, send him specimens from across Alexander's empire for careful study. But Aristotle's science, his theory of everything, his scientia, suffered from several impediments from our modern perspective. So from today's perspective, we would look at Aristotle's scientific approach as flawed in some important ways. The four characteristics that were problematic from our perspective was his commitment to the Ptolemaic or geocentric cosmology, his theory of the five substances, his insistence on categorical syllogistic structures for scientific reasoning, and his doctrine of the four causes. The Ptolemaic cosmology, you might be familiar with this, but if not, Aristotle thought, as did most of the civilized world in his day, that the Earth was the center of a large system of celestial bodies, and that all the celestial bodies revolve around the Earth in concentric circles, perfect concentric circles. So this was the Ptolemaic model of cosmology. Aristotle advocated this view. Ptolemy came later and he refined it, but the ancient world and the early medieval world were all committed to this idea. However, over time, observations improved so that the simple concentric spheres that Aristotle had hypothesized, that needed to be modified because it seemed to be inconsistent with actual astrological observations. So one example would be when Mars is in retrograde. So the little graphic there on the right-hand side, if we were plotting the position of Mars in the night sky at certain points in the year, we would see it moving kind of in a regular fashion, predictable fashion from lower left to upper right, where it goes ba-boop, 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 ba-boop. But then we start to see it back up, ba-boop, 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 and then it starts to go again, ba-boop, 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 ba-boop. Well, Aristotle had said that the celestial bodies move in perfect circles at a perfect equal rate, and that was invariable. And yet observations seem to suggest that Aristotle was wrong. So what goes on here? This is a closer up graphic of plotting the night sky. And Mars in retrograde. Here's another rendering of this same sort of deal. This doesn't all happen in one night. This would be photos taken over successive nights. Without getting too technical, we needed to tweak the Aristotelian model for how the universe operates. In the simple modification of the system, the planet revolved in a perfect circle, an epicycle, but the epicycle itself was revolving on another perfect circle, the different. So this is how Ptolemy and ancient and medieval astronomers made sense of the night sky, right? And so we see here, So we see here the planet is moving in a perfect circle, but this red perfect circular orbit of the planet itself is moving in a perfect circle around the Earth. So the epicycle is orbiting along a different, right? Now, with this modification, you could maintain that planets move in perfect circles at a constant rate, even though, and what appears to be Mars backing up in the night sky is not really Mars backing up at all. It's simply Mars doing the loop-de-loop, but it's still moving in a perfect circle and a perfect forward motion at a constant rate of speed. I don't know why I threw that in there, but I just thought it was nice. Here's another idea of the epicycle and the different, and you can see where you get a loop-de-loop pattern when you employ this explanatory model. Claudius Ptolemy was a Greco-Egyptian writer, known as a mathematician, astronomer, geographer, and astrologer. And Ptolemy provided a mathematical model for calculating the celestial events. However, Ptolemy found that he could not reconcile the older notion with the additional Babylonian observational data then available. So he acquired more observational data, and he even had to modify what was starting to already become a somewhat complicated model. The angular rate at which the epicycle traveled was not constant unless he measured it from another point, which he called the equant. Without going too much into detail here, let's just get to a graphic which will make this sense. So what he found was that the slides we were looking at a moment ago weren't quite complicated enough. And so the different did move in a perfect circle, but it didn't perfectly orbit the Earth. It perfectly orbited a point in space that was halfway between the Earth and the equant, a theoretical spot. And this was the center of the different, right? And that's why, from our perspective, things seem to be moving in different speeds and different rates, but it's because it's not perfectly orbiting the Earth, and it's not perfectly orbiting the equant, it's perfectly orbiting this point which is midway between the two. Right. The main point is that he was able to come up with a mathematical model that was able to account for observations. It was crazy complicated, but it worked. Worked in the sense that it did account for appearances. And so it could tell you when things would align in the night sky, when constellations would appear, when planets would appear, when they would no longer appear, when there would be eclipses, etc. And so you could make all of the required astrological predictions and explanations, but you had to appeal to this very complicated mathematical model, which included the epicycle, the diffident, the equant, etc. It was well known by Ptolemy that the apparent motion of the planets could be accounted for equally well by incompatible mathematical models. So note, this is an early tension that existed between a Pythagoreanism, claiming that the numbers, the mathematical models, are grasping the truth of appearances, and the possibility of distinct mathematical descriptions which were nevertheless observationally equivalent. So maybe they weren't grasping the truth of appearances. Maybe they were merely useful mathematical models, but maybe they didn't really describe how the universe really was. Nowhere was that a debate more acute than in astronomy, right? But this is an early instance of a debate between realism and anti-realism within science. Is science telling us about how the world really is? Or is science only providing us with useful models for predicting experiences, but it may not be telling us how the world really is at all, right? So that's not a new debate. That goes back to ancient times, and here we see an example of that. Especially in astronomy, the tradition evolved of not claiming the reality for the mathematical models. In other words, within astronomy, astronomers were usually modest by saying, I'm not saying this is how the world is. I'm saying this math will help us predict what it is we're trying to predict. The task for the astronomer is not to hypothesize about the unobservable nature of things, but to provide a convenient and observably adequate model for things. This is an early distinction between noting regularities and explaining regularities. And again, this is a form of the anti-realism that is related to current debates about about observation and theory and the distinction between the two. So, is it just a useful model? To suggest that the Ptolemaic cosmology is merely a useful model but may not be telling us how the world really is similar to contemporary views of science called instrumentalism, naive positivism, operationalism, or constructive empiricism. Constructive empiricism is the version of scientific anti-realism promulgated by contemporary philosopher Bas van Fraassen in his famous book, The Scientific Image. Van Fraassen defines his view as the following: science aims to give us theories which are empirically adequate, and acceptance of a theory involves as a belief only that it is empirically adequate. So what Van Fraassen is saying is to say I accept the theory of atoms as I accept that theory is not to say that I really believe there exist such things as mind-independent realities called atoms. I merely mean that these theoretical models are adequate for tracking experiences and predicting future experiences. Ptolemy himself was inconsistent on this issue, not unlike Stephen Hawking's, that's personal note that I have, usually stressing Pythagorean realism. So in other words, usually Ptolemy himself was suggesting that his models were actually telling us how the world truly is. But then sometimes he would weaken his position to say he was only claiming to be saving appearances. In other words, what Van Fraassen would say, presenting us with an empirically adequate model. He nevertheless considered heliocentrism. He never considered heliocentrism plausible, though. Ptolemy never thought that it was plausible to imagine the sun was the center of the celestial system. So he just never thought that was a plausible model. In Ptolemy's hypothesis, he went beyond merely providing a mathematical model for calculating celestial events to present a physical realization of the universe as a set of nested spheres and computing the dimension of the universe. He introduced the theoretical postulates of the epicycle and the equant to match the observed movements of the celestial bodies, except the sun and the moon, with the existing presumption that they all exhibit uniform circular motion. Right? Again, it worked, his models did, in the sense that they were able to predict the regularities as observed, but it was crazy complicated. It's worth mentioning, however, that even in ancient times, this was not universally accepted. Aristarchus, I think, of Samos, was an ancient Greek astronomer and mathematician who presented the first known model which placed the sun at the center of the known universe, with the Earth revolving around it. A second commitment of Aristotelian science. So the Ptolemaic model of the universe was one commitment. A second one was the idea of 5 substances. What Aristotle maintained was the terrestrial sublunary world was comprised of 4 elements, each with its own nature and characteristic way of behaving, changing, and moving. So the terrestrial world was composed of earth, water, fire, and air. But the celestial realm, according to Aristotle, had to be quite different because the celestial realm was eternal, unchanging, and perfect. Well, nothing in the terrestrial world is eternal, unchanging, and perfect. Therefore, the celestial world must be some other kind of substance. And he reasoned it had to be a fifth substance, the quintessence, right? The fifth essence, the fifth substance. Unlike anything terrestrial, its motion was unlike the motion of physical things down here on Earth. Nothing here on Earth moves in perfect circles. Nothing down here on Earth are perfect spheres. Nothing here on Earth is timeless and eternal like the celestial bodies are. Therefore, the terrestrial and celestial worlds must be governed by different kinds of causes and composed of different sorts of substances, or so Aristotle taught. Further, Aristotle insisted on a syllogistic structure for science. For Aristotle, real science must proceed deductively by valid syllogisms, where the first premise is a fundamental, necessary principle of nature. So you've probably seen, what do you call it, syllogisms that look like this: all men are mortal, Socrates is a man, therefore Socrates is mortal. And that is a valid syllogism, right? And it's a good example of a valid syllogism, but it's also a perfect example, paradigmatic example of a scientific argument, according to Aristotle. The first claim, all men are mortal, is supposed to state a necessary universal truth. He thought that when you truly understood the nature of humanity, you would understand that an necessary feature, not an accidental feature, but a necessary feature of human nature was mortality. But also, when you understood what Socrates truly was, essentially, he was essentially a human being. He happened to be an Athenian. He happened to be married to Xanthippe. He happened to have a snub nose, but he was essentially a human being. Well, if all men are mortal necessarily, and if Socrates is a man necessarily, then it follows that Socrates is mortal necessarily. So we have all necessary true claims. Again, the major premise of the syllogism is a necessary true claim arising from our knowledge of the nature of humankind. The minor premise is an observation of the essence of Socrates. He is essentially a man. He is only accidentally snub-nosed. Therefore, the conclusion, which follows necessarily from the premises, deduces an effect or consequence from the cause. Socrates' mortality is a necessary effect of his formal causality. It's caused by his form, by his essence, by his humanity. Aristotle required that the general principles, though arising from observation, should be ultimately self-evident or necessary truths. The motivation here is to avoid arriving at claims which describe only accidental regularities. Rather, general principles should be self-evident necessary truths reflecting the essences of objects and relations in nature. The problem is that it's hard to see how we can get necessary truths by observation. So contemporarily, we might look and say, that man's mortal, that man's mortal, that man's mortal, so all men are mortal. Probably, but that's all we would ever get, probably. That's a different kind of reasoning. That's known as induction. We've talked about that, or I believe we have, right? But that's not how Aristotle thought science should work, because if I only have probably, then I might have hit upon an accidental regularity, not a necessary regularity. And therefore, I can't know that all men are mortal. Well, he thought we could know that all men are mortal, but that's because he didn't rely on induction. What did he rely on? That's less clear. Now, there's nothing wrong with deductively valid syllogisms. The problem arises as how we are to get those necessary universal first principles. It seems anything which we come to know through observation seems to be contingent, not necessary, probable, not certain. Aristotle never satisfactorily addresses this nor did centuries of adherence to his view of science to come after. So this is why this also poses a problem for Aristotelian science, which is what medieval science came from. And then finally, there is Aristotle's doctrine of the four causes. This is the Aristotelian doctrine, which holds that to truly know what a thing is, one must gain a complete and exhaustive scientific understanding of that thing. One must know four things about it. That is, to explain what a thing is, why it is what it is, and why it behaves and develops as it does, one must know four things about it, according to Aristotle: material cause, efficient cause, formal cause, and final cause. And I won't belabor this here because it's in the notes, but basically he thought that a true scientific understanding of an object would need to address all of these causes, all of these qualities of a thing. I'm going to skip by this. It's in the notes. I'm going to say the notes. It's in the notes. It's in the notes. One of the chief problems, though, is that he thought that all things had an end or a purpose towards which they tend, or a goal. He saw all of reality as sort of goal-driven. They have ends, as I say, to which they tend. The Greek word for end or purpose is telos. So he thought natural things had a telos, an end towards which they tend, and understanding why they are the way they are, why they behave the way they behave, why they don't behave in other ways, requires understanding the thing's telos, the end towards which it tends. Aristotle had a teleological worldview. Natural living things like apple trees, badgers, fruit bats, date palms, etc., had purposes too. And for the natural thing, their final cause, telos, was their formal cause. In other words, what is an apple tree supposed to do? It's supposed to instantiate apple tree nature, right? Presumably be the best darn apple tree it can be, but it tends towards apple tree nature. And he thought this is why you can explain apple trees' behaviors. This is why apple trees get blossoms in the spring and apples in the fall and remain dormant all winter long, because that's apple tree nature. That's the end towards which they tend. I think I said that already. I did. All right, this is also in the notes. So I'm going to stop here, not because we're done, but I want to talk about what happens next. So I'll do sort of an epilogue here, and then we'll pick up in another lecture right after this, right? But Aristotle's view of science became extremely influential in Western thought by the late Middle Ages. And it grew into a full worldview called scholasticism. Perhaps the finest example of scholastic thinking is Thomas Aquinas, but there were plenty of others, and this was widely agreed upon. But the whole edifice of scholastic thinking, which was founded on Aristotelian thinking, started to be questioned and eventually abandoned with the advent of modern philosophy and the advent of modern science. And so the science we see today stands in contrast and contradistinction to the scholastic Aristotelian medieval science. So that's what we'll discuss next. All right. So I'm going to conclude at this time, and then we'll pick up with the second half of this lecture in the subsequent lecture to follow. Have a pleasant rest of your day.